everyone should kind of know that, because like this is the thing that we've had. If you go to serverless first, and
I'm going to turn over to Aaron. Aaron, take over.
Yeah, just on that, so before I get started on what I was here to talk about. Yeah, just with serverless, like with Lambda in general, the best thing to do is to just get a feel for it, right? Go through the pain and suffering of how to manually deploy Lambda, right? Because understanding that and understanding how things are composed, if you went straight to serverless, it's a lot easier, but you won't necessarily have the context when it doesn't work, and it often doesn't work. There is actually a new, thing that was announced for reInvent, a thing called serverless application model, which is an AWS supported thing, which is part of CloudFormation. It's sort of a DSL, AWS's own DSL on top of CloudFormation, for doing serverless deployments. And it actually looks, it's a lot simpler than serverless, but it isn't as powerful. But it also might be an area, like I'd also suggest doing it manually, going into the console and uploading stuff to S3 and then going and registering that. Just getting an understanding, going and manually entering API gateway endpoints, you'll hate it within about 10 minutes, but you'll get a feel for like when it doesn't work, where to go and find, oh, is it an API gateway or is it in Lambda, or like where the problems are.
Yeah, that's one of the, right, that it does magically do a bunch of things behind the scenes that you're like, if you don't know where those things are, you will be like, what happened? Why is this not working? Where's the issue? But once you start using it and understand it, it makes it a lot faster. So, yeah, there you go.
Cool.
Thanks.
What does serverless have to do with the term infrastructure as code?
What I'm talking about is slightly different, but it's kind of related. So really so let me, sort of talking about CI/CD. So let me get a feel first for the room's sake. So if you would put yourself in the dev camp, put up camp. Right. If you put yourself in the ops camp. Good. So who here is practicing continuous integration on a daily basis? What about sort of continuous delivery? Okay, cool. Okay, so what I'm going to talk about today really is about, I'm going to kind of skim over some CI/CD concepts and principles, because most people kind of sort of put their hand on, had a bit of an idea of what that is. And if anyone's, just jump in anytime if you've got any kind of random questions. So, well, who am I? So my name's Aaron Walker. I'm the technology director at a company called Base2 Services. We're based out of Melbourne, Australia. And we've kind of been working in this space for quite a long time. We sort of started out as a development company, building software for customers, and we kind of moved into the more kind of infrastructure management cloud. We sort of really only worked. We've never done traditional infrastructure management. We've only ever done cloud management. And so we've always taken a very dev-centric approach to that. Being a development company, we've kind of always managed infrastructure that way, and always had a strong focus on developer workflow and developer experience. So, this is, who here's built something like this? Pipeline, CI pipeline. Hand up. So we've got, source control, we've got Jira, maybe somebody's moving some tickets around or some cards on the wall, or maybe even you've got your CI tool doing that. People checking in code, kicking off builds, using horrible tools like Bamboo. And then maybe you're in the cloud and using AWS, and you're kicking off CloudFormation and deploying applications and using a horrible tool called OpsWorks or something like that. To do that, or even Beanstalk. So yeah, a lot of organisations have got that, right? They understand that, right? They understand that they need to automate the build process and deployment process, and they've probably done that, right? They've probably gone to the extent and done the investment, put the time together to do that, right? So they've got this pipeline where everyone's happy, and you basically go home, right? Because you're done. Like that's it. You know, that just works and, you know, never needs to change. Doesn't need to scale. Right, so you're done. So, what's the reality, right? So what's the reality of most CI/CD processes that we tend to see, right? They tend to be extremely brittle, right? So they're susceptible to, you know, I've just mashed all these things together and they all work, but what happens when one changes or I need to do something different, right? They tend to break, right? And they tend to be the number one, and this is what we see across all of our customers. We kind of get this through a trend every now and then. After a while, you get into place, it becomes the bottleneck, right? So you've got all this automation in place. It's all great. It all sings and dances, and you run it through a CI pipeline, but that becomes the bottleneck, right? So if something breaks, no one can deploy, right? You're kind of blocking things. So it becomes the most, you know, often a lot of people don't treat the sort of the CI infrastructure and CI pipeline as if it's production, right? They just, you know, it's thrown on a couple of servers in the corner, running a Jenkins box under their desk, or worse, on their laptop, which I've seen laptops sitting in the corner with Jenkins running on it. All our builds happen from this laptop, and if that laptop breaks, we can't deploy to production, right? So that's really that becomes a really massively a big problem, especially as you start to scale, right? So as you start to do this and you have success, right? One of the things that, you know, I see this a lot with sort of, you know, companies that are first kind of going down the CI path, where they're, especially not just CI around doing applications is pretty well known. Like we've been using kind of build tools and build infrastructure to do, you know, to do application builds, and now really in the infrastructure space, you know, we're starting to integrate those pieces, right? We're starting to integrate our Chef server, our Puppet server, you know, if you're deploying to AMI, we might even be using that to go and build a bunch of AMIs, run some provisioning code, take AMIs, push those through, right? So we're doing a lot of that. It's becoming the central point. And, you know, over time, it sort of starts to creak and groan because, you know, you just throwing lots of builds at it, no one's really kind of giving it any kind of attention. And one team does it one way, another team does it another way, they've got a slightly different deployment model, a slightly different way of setting up things. So you end up with kind of this kind of really organic environment of different tools, different technologies, and you know, they become absolutely critical to a lot of businesses, right? I've been in a lot of situations where we've gone into customers where they've had these processes, and it's like, don't touch it. Don't touch the CI server. If it breaks, man, you know, it's going to take us days to kind of get back. Often they're not backed up, so that's the other thing. People go in and create Jenkins jobs to their heart's content. They click on, pick a new job, and punch in a bunch of shell script into the thing, and now that's a critical thing, right? And then the next person comes along and copies that job. And they go in and tweak the script. Just that little, I just need to do my little bit. And or they fix a problem, but they don't go and fix the original job, right? So you end up with this sprawl of scripts and fragments of Ruby and Shell and Python and, you know, whatever you feel like, and there's no management around that. They're hard to change, right? Once you've got them established and everyone's relying on the pipeline for, especially if you're going down the path of, you know, if you're going down the path of sort of a continuous delivery where you've got friction, now you've created frictionless ways to deploy to production, you know, and you want to change that. Well, how do I change it? Well, I've got to stop people deploying to production to change it in a lot of cases, right? So how do you do that? So they become really hard to change. And as you try and roll this out across an organization at scale, that becomes even more so. So I'm going to do. So at base 2, this is classic. These are the problems we did. We built pipelines that were exactly like that for our customers. Brittle, hard to change. We were duplicating stuff all over the place. And so one day, you know, we kind of sat back and kind of looked at what we're doing and how we're doing it and the approach that we were taking. And essentially, we're sitting in a meeting room having a talk, and someone said, "Wouldn't it be great if we had CI in the box?" And I kind of laughed, and that'd be funny. And so essentially that kind of spawned a project that we've been working on for, I don't know, probably 18 months now, on and off, which is really, so how do we solve some of those problems? How do we solve some of the standardization problems? So when I build a CI environment, how do I make sure that it's consistent across lots of different customers, lots of different teams within an organization? Or you get to the problem with a lot of organizations, we only have one CI server. The entire organization relies on one. There's a recipe for failure. So then you give teams their own CI servers, and then how do I build standardization across those teams? The other thing that we wanted to do was really promote the concept of, okay, so I want my pipeline, when I build a CI server and I create the jobs, I don't want to create them by hand. I want to define them as code. Like everyone has an understanding of infrastructure as code. Well, why can't my pipeline be code? Right, so why can't I define that process as code? And why can't I even define how my CI environment is configured as code? Right? And so we've thought about this and thought about how do we do that, right? How do I create an environment where I can define different services and different tools and technologies and kind of define that in a way that I can kind of standardize that process. And so we sort of spent a couple of days at an internal hackathon, and we kind of hacked something together to do that and sort of what would that look like. And we ended up creating a thing which we now affectionately refer to as Cinebox. So which, if you spell it out, is CI-box. Project names are hard. So let me, where are we? Right, so we have a bunch of public GitHub repos. If you go to the basic service, at some point in time I'll spin it out as a separate organization when I can be bothered. But basically, if you search for anything that's Cinebox, you'll see there's a whole bunch of repos here. The sort of core one is the core kind of framework. So we're at Amazon, we're big. We've been working with Amazon for about 10 years. And so, it was obvious for us to kind of build an Amazon-centric tool. And we wanted a consistent environment that we could deploy to our customers. And that we could create sort of this repeatability and kind of solve some of those issues around, having, unrepeatable, unmanageable, provide clear upgrade path and manageability around those sort of environments. So we ended up creating this project called Cinebox ECS. As you can imagine, it leverages the Amazon Elastic Container Service to do that. So essentially what we do is we build and deploy an ECS environment and then have ways of configuring and deploying different services to that environment, kind of all of the sort of underpinnings that go along with that. So what I'm going to do is check that I'm in the right tab, the right terminal. Right, so it's basically, really all it is a bunch of CloudFormation, a bunch of some Ruby scripts. There's some sort of standardized process there. So basically we can go through this and I can run, can everyone read that?
Yeah.
There's an advantage to having very low resolution on that.
I see people moving forward and they're going to say, yeah.
Let me put that in. So this is, we wrote this interface, this sort of simple CLI interface. No one internally uses it anymore because all it does is spit out a YAML file. You just go right in the YAML file. I thought I'd go through the interactive part. So we'll call it DevOps. DevOps. Sorry, I did one before. So the AWS account, I'm going to skip that because I actually have one prepared earlier. So I'm just going to skip that question. So you put in your AWS account. You put in where you want to put it, US, East, 2. Put in Oracle High. S3 bucket. So this is basically all the things of where it places things. So I can top level AWS account. So this basically automatically registered all of the DNS records for it. So you just need to give it a valid Route 53 managed top level domain. In this case, I have a domain that I can't use, which is for another demo I did. Right. Really all this does is go and create a bunch of files. So if I go to here, you can see that's created this directory, and inside here is a configuration file. Right. So that is basically, you know, those questions it asked me, plus a bunch of other things. So who here knows of CloudFormation? Who here uses CloudFormation? Cool. So who here writes CloudFormation in JSON or now in YAML?
YAML.
Right. So we use a DSL. We use a Ruby DSL called CFN DSL because I hate writing. Well, when we started, they didn't have YAMLs. They didn't have YAML support. I may not have gone down this path if I had a YAML support first, but
Did you develop the DSL yourself?
no, it's an open source project called CFN DSL, which we contribute to now.
What's it called again?
CFN DSL.
CFN DSL.
It's written in Ruby. It's probably one of the more popular DSLs for writing CloudFormation. And the reason why we use it is because what we do, typically you can't do, how we kind of manage our CloudFormation, you can't typically do without a programming language behind it. Because we do all sorts of things, horrible things. Like create horrible VPCs that can render into every single region in every single account based on your account. And I don't know how well you know AWS account mapping, it's kind of funky. It's per account and it's per region. It's just crazy. But yeah, so we work around it and do that with a DSL. So basically what this does is really, yeah, this is just a bunch of, this is a parameter file that we feed into our CloudFormation generation process. So this generates CloudFormation. So I'm going to go back and switch to the one that I know well. It worked last time. So this demo one. So yeah, basically that's valid for the reality. And you know, like we're good. You know, we restrict our environments, you know, by default, so they're open to the world. So it also one of some of the other commands that you can use. So it can also generate some self-signed certificates. Actually, I'll just do the I won't actually. So, like, you can create the IAM service certificate, so it generates a self-signed certificate locally and then uploads that to Amazon for doing SSL endpoints. It also generates a key pair that it uses to launch the instances, and kind of manages that. And you know, so you can see for the one that I generated earlier, it's generated a key, a certificate, private key, and cert, which is used by the load balancer that it creates, and then the actual instance PKEY key if you want to SSH into that environment. Not that you should ever do that. You shouldn't need to. Right. The other thing that it's done is it's generated these services. Yeah. So what this is what things do I want to deploy? What tools do I want to deploy to my my Sandbox environment? So in this case, what I'm saying is I want to deploy Jenkins, and I want to deploy, I don't know, probably no one in this room knows what Audio is. If you do, I'm pretty impressed. Audio is a Java Smart JMX monitoring tool. Some of our customers use it. We do a lot of Java stuff, which is why I knew the answer to who created the Collections API, Java guy from way back. So we do a lot of stuff on the JVM, JVM. We specialize a lot in the JVM and how to scale that. So we have a lot of experience there. But the idea of this is that there are a standard set of services that we kind of have built, and they're part of the Cinebox ECS project. Let me go and show you the services that are currently. So this is we support. This is an old. I didn't want to break this environment. We support a bunch more than that. So Bitbucket Server, Audio Jenkins, Nexus, other Java main, Java development made into Nexus as a repo, so we can deploy. So the idea is that what we're doing is creating an environment where, and you can easily add your own, right? All these are CFN cell templates that define an ECS task. So you can basically, we want to create a new service to deploy to your Cinebox, simply copy the template, change and generally the only thing that changes is the container image. So so anything you can run in a Docker container can run on Cinebox. Internally we have a bunch of sort of pre-packaged tools. So like we have an OpenVPN to run on Cinebox, so it can be deployed as part of that. Elk, so like an Elk stack, so Logstash, Kibana, Elasticsearch. So they can all be deployed through this platform, right? And simply specify the definition and then actually defining those in the services channel, right? So so they're the two core parts. So let me spin this up and then I'll talk. That will actually take a little bit. So let me just cheat. I never remember these commands, even though I read them. There, actually copy and paste the eval string. So all this does is set up a bunch of variables that the array command can understand. So I can do. So let me just do a quick status. This will tell me that whether or not it's running. So it's not running, so it has to be created. So let me just go through this. Typically the process is, so we generate it. All this does, so what this does is render the CloudFormation. So that all that's done is taken the Ruby DSL and passed it through CFN DSL and spat out a bunch of JSON, which you never have to read ever again, which is great. So when you go and debug CloudFormation, debug Ruby, not JSON. It's great. Occasionally you have to go and jump in JSON, but not often. So then we need to deploy it. What all this deploy does is sync that to S3. Take those JSON files and put them in S3, so that we can then launch CloudFormation. So that's now pushed that up. Then next, what we can do is simply go red. And then I'll jump over to the AWS console to show you commands. Right. So that's just launched CloudFormation in red. Let me jump back to here and go back to my CloudFormation terminal. And you can already see that it's already started, right? So it's already started building that. It's building the VPC template. So we use nested stacks because I'm a fan of nested stacks if you're a CloudFormation person. Some people have nested stacks, some people aren't.
You say nested stacks?
Yeah, nested stacks. So instead of one CloudFormation template, or you're crapping it, we split it up. Creates better reusability, creates faster updates because it's not scanning all the resources.
There is an actual limit to, I can't remember if it's line numbers or the amount of bytes and stuff. That's why we
And so
started.
often you have to split them. And that, if you get to that point, we've never, because we've always used nested stack, we've never hit that point. We've never hit those limits because we don't try and split all the ones.
We had a lot of embedded bash at one point.
Well, that's, you
And
know,
that got nasty.
yeah, you could, should be doing that.
We learned.
Yeah,
I'm saying at one point we found the limit.
Exactly. We learned that as well. So while this is running, I can go back and talk about some of the other pieces, right? So once this spins up, so at the end of this, so when this is finished, what I'll have is I'll have ECS cluster that's CloudFormation managed. I'll have Jenkins deployed and pre-configured, mostly pre-configured. So there's some de facto standards. So this is where some of the other projects that we work on. So there's this Cinebox containers, which is basically, these are all the things that we've packaged up and run. So where we've used if you use standard Docker Hub images, right? So what we've done is create customized Docker images for various services. So for running a Chef server, for some of the Cinebox stuff itself. So the idea you can run Cinebox inside a Docker container, so you don't have to check it checked out on your machine. Jenkins CLI, the Jenkins master itself, which is this one here. And then we have two, which we have standard Jenkins slave, and then we have the Docker and Docker Jenkins slave. So one of the things that we want to do typically with these environments is run Docker builds. So we use a technique which allows you to get to run Docker in Docker, right? So we run a Docker host inside a Docker container, which sounds crazy, but it is kind of crazy because there are some interesting constraints to doing that. But typically, what that allows us to do is create very clean build environments. Now, it has some interesting behavior with VFS, and if you're a Docker nerd, we can have a 5-hour discussion on VFS. But really, we kind of did that because it meant that we can create. So what comes up? Typically, what happens when you spin up a Jenkins is pretty easy to run. But when it comes down to, it'll create a couple of executors on the master, which isn't very useful, right? You want slaves to be up in front of that. And so part of what that framework does is basically automatically attach a slave, which is a Docker container running in a separate Docker process to kind of do that. And then you can attach more slaves as well, which are either Docker or non-Docker, like using the EC2 plugin, ECS plugin, or scaling up Jenkins, right? Just see where we're at. Hopefully we're still
You're on the status.
we're on the real lake. So we're creating a cluster now, so it's spinning up the ECS cluster. So it's spinning up an EC2 instance, creating the having that join the cluster. So if we actually go and look at ECS, it should already be there. Cluster will be created. Yep, there it is. That's my cluster. There will be no instances yet, so I suspect it's not joined yet. So that, that's my other demo. The other day. Yeah. Oh, wow, we're in a really old template. Spinning up NAT instances, how scary is that? Rather than using NAT gateways. This is an old version of Cinebox. Spins up NAT instances. The new version, which I can check out and test, haven't tested it with this demo, is use NAT gateways. This is like generation 2. We're now like generation 4 or 5. Simple. So it's once they're done, which they should be done shortly, it'll move on to doing the ECS instance. So let me just search environment all throughout the other ones. Okay, so that's cool. So I'll be able to log in a couple of minutes. I'll be able to log into that. But then the problems start, right? I've now got a Jenkins instance, and I've let developers loose on that instance, right? So they're going and clicking around and creating new jobs, that kind of stuff. So there's been some recent improvements in that space with Jenkins pipelines and those kinds of things, but that's cool. Which I could talk about some of that. But there was what we found is what we were doing is essentially a lot of the same jobs for a lot of our customers, right? So we were creating a standardized pipeline which would take a pull request, run a build, merge that, maybe kick off a CloudFormation stack, or once that build's finished, take that build artifact and bake it into an AMI. Take that AMI, render it into a CloudFormation stack, do a CloudFormation stack on it. So we were doing that lots and lots. And so we got to the point where we were creating scripts to do that and using Jenkins managed script plugin and kind of, so we didn't have to put the script in one place. But when we got to setting, provisioning that for a new team or a new customer, that process would take, half a day. So, we got kind of bored with doing that. And it got like error prone, and every one was slightly different. Depending on how the developer was feeling, it's how standard that one was, right? So they, or what they've been told about what the process was, right? And so we decided to kind of fix that, right? So how do we do that? So we created a DSL. Can't do that. So we created this other project, which and this leverages. So Jenkins, there's like two primary DSLs for sort of orchestrating Jenkins, right? So for doing sort of more jobs as code. There's the pipeline plugins, which basically allows you to kind of define the pipeline as code. And then there's the other one, which is called the job DSL, right? So the job DSL is a Groovy DSL, which basically allows you to write Groovy code to kind of define what a job looks like. And that was great, and so we started using that. And so we had a bunch of Groovy code sort of littering everywhere. And again, it was, we even had a shared repository and we pull in Groovy scripts and stuff like that. But, we've got a fairly ops heavy team, and they've got good development skills, but learning yet another language to do that. And really, they were doing the same things over and over again, copying and pasting these chunks of Groovy script to basically check out a Git repo and run a build, whatever that would be, in install or Composer or Maven clean install, those kinds of things, right? And so there's quite a lot of code to do that with the job DSL. And so there had to be a better way, right? It had to be like, okay, so how do I have sense, how do I go and take a sort of a leap out of the convention over configuration, right? So let's build some conventions, right? So let's build a standardized way. If I'm going to define a job, if I don't specify a branch for that job to build, it's a pull request. It builds pull requests, right? So I don't have to specify that, right? So have some sensible defaults. So essentially what we did was create, and I'll give you a look at an example of what that looks like. So that was the other thing is, well, what about the defaults for jobs, right? So let's just, I know that I always want to use the credentials for GitHub. I want the credential ID that I want to use GitHub. So I don't have to specify that in the job anymore, right? So every job inherits that, unless they override it, right? So there's basically a way to basically, specify a bunch of sensible defaults. The other thing is in the pull request plugin, what organizations do I want to just allow build without me having to go and specify them, right? So that's using the Jenkins GitHub plugin. If I'm on Bitbucket, if I want a Bitbucket build, then what do I need to do? What's the default Slack channel that I want my build notifications to go to? Are there any standardized build environments that I want to specify? So these are all like job defaults, right? So if I don't specify, if I don't override this in the job, these are what all jobs are going to inherit. So we have this model of, we can just define what the defaults are. And in most cases, you don't even have to define most of the defaults too, right? So if you don't even specify, these are the defaults for a lot of them. Some of them don't make sense, but the ones where, like directory credentials, if you don't specify them, the tool will use those values. So what does a job look like? So here's a really simple job. So I have a job, it's called example pull request, it lives in a folder called example. So we use the Jenkins folder plugin because that helps kind of organize things a bit better. What repo, right? So I didn't specify that to be GitHub. I just specified a repo. It knows by default, if I don't specify it, it's GitHub. If I want Git, then I have to specify like a pure Git of something else, or I can specify Bitbucket. Right? So I didn't specify it. I could also put GitHub and I could nest that and I could get more control over the GitHub plugin. But if I don't specify it, we're going to assume that you're using GitHub. And then that the script that I want to run as part of the job is here, and that's where this default directory is, right? So what it's doing is it's actually loading the scripts out of this directory that match that and putting that in the shell version. So those scripts now live in this Git repo, right? So they now live here. So we can specify that that shell script lives. I can go to here. And there's a script directory, and there's my script. So they're now in source control. They're now versioned, right? So they're now managed. Let's go back to the. And so, in this, this is the sort of example one. So every time we add a new feature to this DSL to configure something new, we kind of add an example. So there's GitHub using the SSH protocol, not using the HTTP protocol. So I can specify that GitHub protocol SSH. So now I've overridden the protocol instead of doing an HTTP. So instead of the credentials that I'm using in Jenkins being a username and password, they're now an SSH key, which would be probably a more common pattern, right? But I probably should make that. A very common thing you want to do out of a build job is you want to archive an artifact, right? So you specify archive and what do I want to archive, right? The other one is, okay, what happens if I want to trigger another job? So a typical thing you do in Jenkins is build something and then trigger something else. So we've kind of built that into the DSL as well. So I can trigger that. And I can trigger with parameters. So if I've got some build parameters like the current build number, I'm building the app and I want to propagate the app build number into the next build phase so I can use that build number to, I don't know, bake something with that build number.
Does it check dependencies when it does that?
Yes. Yes. Yeah. That's basically all it does is put the trigger to see if that job exists. If that job doesn't exist, it won't fail. The other thing is maybe part of my script or whatever that's run has committed some locally to a branch. In this case, maybe I've done a merge from a branch to master and a merge from master to production. And then I want to push those branches back at the end of the build job, right? So all of that kind of encapsulates that behavior. If you did that, and I can show you once we deploy these jobs, I can show you, it can be quite a lot of steps in Jenkins to do something as simple as that. There's, what if I can archive artifacts on patterns, what else can we do? There's, different credentials, there's some, there's quite a lot of examples in here around, different branches, Bitbucket with a custom artifact, custom branches, an example using cron expression, so I don't want to build using a GitHub push or a trigger, I actually want to poll GitHub, or I want to run a job on a specific schedule. That's all kind of support. And there's stuff that's not in here that's supported. It's fairly easy to kind of add to it, right? So hopefully I've talked long enough. Roll back. Okay, that's all right. I can cheat, and I can give you. This is good actually. Let's have a look. Why did it fail? I love CloudFormation debugging. It's so terrible. Let's have a look at this file. This screen is really hard to use. That's why I mean.
Command minus.
Out of here.
minus a couple times.
Yeah, yeah. So.
Pretend it's
What's the
1996.
translation? Minus, negative.
Oh, you should go to Australia? Opposite of plus. You could close it down.
Collapsed, like, I've never seen that collapse like that. I've never had a narrow off screen for those tabs.
Can you hit command dash?
Yeah,
Is that doing it?
yeah, yeah.
There you go.
Great, resource cancel. Probably failed on one of the tasking. It wasn't that stack that's failed. If it's this stack that's failed. So it must be something in TCS services. There we go. Aha, I forgot to change the. ECS was unable to shoot a roll that I deleted by accident.
So you're saying you had really good security, you blocked yourself out of it?
Yeah, I deleted my own IAM.
You need a versioning in your permissioning.
Yeah, it should go in and just do a hack in the counterpart, just destroy everything. That's what I did. Okay, so that's not a problem because I can show you the most awesome feature of this. Right. So, because I got really sick of spinning up Cinebox just to test Jenkins and jobs and stuff like that, and testing it on live, custom CI environments. I just don't want to break them. So I created the ability to basically run. Hopefully we've got this in one pipeline. I don't know. Use Docker for Mac. Who uses Docker for Mac? Who hates Docker for Mac? Keep putting your hands up. So who runs out of disk space with Docker for Mac all the time? There we go. Right. Yeah. So we basically, what I decided to do was, well, it's all Docker. I just run all the containers locally. So I can basically run most of the Cinebox containers locally. And I've got a compose file, which is part of the Cinebox Jenkins project, which spins it all on. So you can run it locally as well. And so that's finished our leading.
Ask a question all this.
Yeah, so fire questions away, Buzz, Johnny.
So, this is not my realm of expertise,
Yep.
but I'm beginning to work a lot more with developers that are doing this.
Yep.
And a lot of what you've shown and talked about is already built into like GitLab. So, like, what's the difference
What do you
between
mean?
what you're doing? Well, like all the CI, the Jenkins, the having all the repository kickoff fires, they use
yes.
Mattermost instead
Sure.
of Slack, but they dump all their stuff into it.
So GitLab has packaged together, we just got the enterprise edition. GitLab has packaged together as part of its application.
Yeah, so how do you define your Jenkins jobs?
So,
So how do you define,
YAML file that you just commit with your
Yeah.
thing.
and that's the definition of the Jenkins job, right? Yeah, so it does exactly what it uses, the similar, exactly the same tooling behind the scenes.
Okay.
Yeah, it uses the job itself. And another thing I'll show you, which is the pipeline stuff, so which is also very useful, right? So then there's, because that brings me on to the next, like I can kind of, I thought it would down, but actually thought I had those images, but I did wipe my Docker Mac VM the other day. So another project, as part of this sort of family of projects, is a project called Pipelines. Pipelines is another plugin. So this is Jenkins is famous for plugins. But basically what it allows you to do is you can specify the build pipeline as code. In this case, it's a simpler Ruby DSL. This is why there's competing tools in this space, but they do different things. One of the advantages of, so I'll show you what a basic pipeline might look like. So if I go that's a board. So essentially that is the definition of a pipeline for building, running a build within a Docker container. So basically you specify what image you want to build with, what tag that image is going to be, what arguments you want to pass into that build process, and then simply it runs docker build -t blah blah blah, packages it all up, pushes it to a registry. So it's essentially custom DSL for, and then you can consume that in a pipeline, where you can just go docker build those values, right? And then it will essentially run a build using Docker, which is similar to what the GitLab does. And you define your pipeline as code, right?
Yep.
But so that's just the Jenkins piece. So what we've kind of done is with the environment, the Cinnabox environments that we create are for not just builders. Therefore, up until recently, we were running Docker registries on there. We were running something that I'm gonna as soon as I get back home, or probably on the plane on the way home, is I'm going to build support for ECS's container state service, which is the new right-hand scheduler for ECS, which is based on a project called Blocks, which I'm becoming part of, which just was launched last week as part of at Reinvent, which is basically the ability to write your own custom schedules. I don't know who's familiar with ECS, right? Who's worked with ECS? Okay. So ECS is basically Amazon's container service. So think of Kubernetes or Mesosphere or Docker Swarm. It's Amazon's variant on that. And it's pretty limited, right? When it first came out, it was pretty, it didn't really have a lot of features. It had the most awesome feature of all of the container scheduling, which is why I started using it, is I didn't have to manage it. I didn't have a master server that I had to make highly available. I didn't have to scale that. I didn't have to worry about that. It's completely masterless from your perspective, right? And that's AWS support. And it was free. So I didn't have to pay to schedule one container in a highly available Kubernetes environment. I have to run 7 servers to get a highly available Kubernetes cluster. Right? So just to put one container on a host, that seems a little. You obviously would do it with one container on a host, but just to do that, right? Just to be able to schedule a single container.
It takes 7 containers.
7 servers. If you're going to do it highly available, they have to be 7 servers. To run Kubernetes in production at scale, you have to have 7 instances because you've got to run 3 etcd nodes, you've got to run 2 master nodes, so that's 5. And then you've got to run a registry separate. Before you've even, and then you've got one infrastructure.
But how does that scale then with the other containers?
Well, you can just schedule with 7 node infrastructure. You can scale, and then you just scale up the Kubernetes infra nodes to run the containers on as much as you want.
You don't have to have 7 servers.
But you have to have
additional-
no, you don't have to but just to get one thing going.
Yeah.
So
It's the overall.
so that's that. Hopefully that's fine.
So your tool obviously is designed for AWS and
It is. So we have an Azure variant, but I won't talk about that.
but you're targeting primarily people in the public cloud. What about organizations like the company I work for where public cloud is available? It's private cloud like OpenStack or
I don't
private
do that.
Azure instances.
We're a public cloud company. So my view, and this is my personal view, public cloud is a stopgap technology. It will go away. There will only be public cloud. There will be hybrid. There will be more than, like AWS is going to be the only cloud provider. But my view is that private cloud is, I've got investment in hardware, and I think I need to own it. So I'm going to do that. And my personal view on that is that that just is ludicrous, right? It is short-term technology, and that public cloud will win.
I agree. I think private cloud is just a fancy word for I own some virtualization and some.
Yeah, and I don't doubt there's value in having it, right? If you're an organization, you've got a massive investment in infrastructure, you might as well eke as much as you can out of that. But as long as we don't focus on those customers, right? So we focus on customers that want to take advantage of helping them out and do it at scale.
Are you looking at after the Amazon stuff and extending to other public clouds?
So,
OpenStack, Azure.
so I probably don't want to say too much about what I think about OpenStack. But public cloud, so public cloud providers like AWS and Azure and GCE, they're probably, my kind of view is, cool. Right now, we have a very long history of working with AWS, so we've been working with Amazon for 10 years. So we have a lot of experience with Amazon, and but we are doing more and more in other cloud providers, but really AWS is really the kind of primary focus for us.
Do you think that, is there a reason to hesitate for sensitive jobs, transactional, PCI, that kind of stuff? No reason to hesitate?
I trust them. I trust AWS, and I even trust Microsoft more than I trust someone to run their own data center.
Good.
That is our big. That is why
I trust them way.
Because, right now, we have ETL jobs that we hesitate because it's technically not PCI. Amazon won't say PCI compliant on it. They're close to it. I think they're going to pretty soon, but it causes hesitation among those that care about PCI standard that doesn't do anything for you.
So we have customers that are PCI level 1, and they're on it wholly 100% on AWS, and they pass their audit every
You
year.
just have them call us.
Every year.
Exactly.
So they're a payment gateway, and they do a very large number of transactions.
But it's not
And
just
they,
that, there's also a lot on the perception of that's not quite true. Like, for example, the reason why we have a private cloud is because I'm in the research side of the Federal Reserve Bank. If you made a credit card purchase in the United States, it's sitting on my server.
Yeah.
Do you want every credit card purchase you made sitting on Amazon server?
More so than the governments, frankly.
Right. Actually, I probably trust Amazon more. I don't know.
So, if federal government, I absolutely agree, because I worked DoD for a long time. I can tell you DoD sucks. But again, Federal Reserve is not government, we're our own entity. Our security guys are actually really sharp. But just the perception of where your data sits for census data, that would freak most Americans out.
Gotta be somewhere.
Even private cloud developers, we're still fighting our security to allow us connection to the cloud. Nobody's using OpenStack right now, so we have no ECS access to it, it's security running on it. Because the private cloud is perceived to be too open, too out of our control to trust from the security standpoint, or rather from the security teams.
Sorry, I asked that.
The thing is that a private cloud is still somewhat where physical security is controlled. With the public, that's not the case. You don't know where that data resides or has access to it.
Or that's the perception. We had, at my last job, we had the same argument, the same security team over Office 365 versus Google Apps. And the argument, the choice wasn't whether which one was a better option from a business standpoint. The perception was Google wasn't secure enough because they didn't encrypt the data at rest. Instead, they broke it up into 30, 40 different data sets across the board.
Tim, who leads the DEFCON 405 group, the pen testing and social engineered his way to the server room and off with servers and all the data underneath it.
I'll do the usual, here's what I prepared earlier. And I'll use internal customer environment that I spun up 2 days ago. So yeah, I mean, to give you, I guess, I go 2 ways with this. So I'll show you the DSL, and I'll render it, and I'll deploy it. But then I can probably, if anyone's interested, I can kind of go into how the AWS, like either way, right? I can go into how the AWS pieces of this work, or we can talk about some other stuff, and then I can finish up.
In the beginning, you said it's hard to change it because you don't want to go change the thing, but you keep people from deploying production. Do you feel like you get satisfied with that concern where it is now, I can deploy a change to my CI pipeline?
Yep. Because what you can do is, because you can roll it back.
Oh, because with the CloudFormation stacks, it's a
And with the DSL, right? So yeah, exactly. So with CloudFormation, it's transactional, so I can make a change, deploy a new service, and if that fails, it's going to go back and it's not going to affect anything. And with the job DSL and creating jobs that way, if I balk a job, I can revert it quickly. Or more importantly, I can develop the jobs. This is what I'm kind of showing you, right? So I can actually run them locally and test them. So I basically now have a test environment, a development environment for building my Jenkins jobs.
Right. That's awesome, actually,
Right.
because reproducing Jenkins is
Correct. Cloning a Jenkins environment, right?
it's always too late once you think, oh, I should be able to do this again.
Correct.
Do you have
Right.
any, so people start off with those job templates and then they build on top of them
Yeah.
in some way?
Yeah.
Do you have any protection against them making manual changes on the Jenkins job?
Yeah, you just run it again and it works.
Because I've ran a Jenkins before and people wanted to make all these manual changes. I was like, it doesn't work like that. And we weren't running the,
So what we do is we
Wipe
do,
their jobs fast
continuous deployment on jobs.
yeah.
Right, so internally what we do is we run our own Cinebox, which manages our customers' Cinebox continuously. So we lap them every commit. Bye-bye, change. Yeah, you might have made a change and it worked, but like for that one job, you didn't go and put it back into the pipeline to go and change. So we actually dog through that process, right? So we continuously deploy our Jenkins jobs for our customers.
And people just learn quick enough that like, I made that change and then
And you might do that like quickly, go and okay, that's cool, and then go back and add it to DSL. Like we're stopping
I
that.
actually like that the other direction. It gives me permission to experiment and then hit the button.
Or you just do it local.
Yeah,
Yeah,
or
well,
local, right?
I haven't gotten this far yet.
See, I thought Kansas City had great bandwidth.
do not have the Google Fiber.
Network here? We do.
Yeah, I'm on the guest network. Yeah, it's probably wrong, right?
Here, let's run it again for you. It'll hit a gigabit.
Yeah, I know that's what I. So, but that's it. I've got an environment. So one of the things that this thing's, one of the things it's done is it's a fairly opinionated way of kind of managing jobs and managing the pipeline. So we attach this slave automatically as part of the provisioning process. So when the containers spin up, it automatically creates a slave and attaches it. This slave is running as a Docker container on the ECS host. And we're able, and Jenkins is connected to it and kind of registered as a slave. And so I can go and create, I'm going to go and do something that I smack everyone's hand in our organization they do is they go and click the new button in Jenkins. No job should be done this way. But I'm going to, because I'm allowed to, I'm going to do it. So, like, you get around, this is typically what happens, right? People go and do this, and they all might set up source code management, they might do Git. In this case, they're not. They might have a build trigger to say, yep, run this when it's pushing to button. Then they might have a build step which executes some shell. Where's the shell step? Shell step. Execute shell. So I'm going to do a Docker version. Run Docker. And the most important thing in every Jenkins job. By the way, DSL does this without even asking you. Activate Chuck Norris. So this is hard coded into the DSL. You have to go and change code if you don't want Chuck Norris plugin. So I thought of that. So that's typically, typical workflow. But this wrapping is terrible. So I can go and build that, and you can see it running. Hopefully not fast enough. That was too slow. Probably because I can't spell this. I didn't click away the no source. So this is what happens, right? This is what you got to do. This is the life of a Jenkins, right? So who wants to do this? Not me. I click on that. This is the other job. I did that.
Is it the PR?
I think it's something.
Oh, I know what it is. Yeah, I know what it is.
Is it GitHub pull request builder? GH PRB.
Stupid. One of those ones there. I don't know how to configure them anymore. You can't do that without.
So your team's all trained to use, so nobody
And they all
uses this
contribute.
actually.
No. And they all contribute to the DSL as well, right? So as we find new things, right? So yeah, unhappy Chuck Norris,
Yeah.
that's what we like to see. So that's now green. I was too stupid. I was never going to see it in a good queue unless I put a sleep in it. So there you go. It's gotten. So I can from this container I can run 5 minutes in. I'll run it. If anyone's interested in that part, I'll come back. We can come and hassle me about that. But I'll switch back to those slides. So there's your CI engineering box. So to sum up, basically, as we found we were doing this lots and lots for different customers, we were doing the same things. So we sort of standardized some tooling. All that, everything that we've done is, I'm not going to use the word open source because it's not. I call it open code. In other words, the code's on a public GitHub repo. You can do whatever you want with it. You can fork it, change it if you want to send a pull request. Great. Don't expect any documentation. But you can raise issues on GitHub and someone will probably look at them, primarily me. But at some point in time, once we've kind of gone through a couple more iterations, we'll probably clean it all up and turn it into a proper open source project with some actual documentation, not some readmes that may or may not work. So yeah, really that's kind of, we kind of, that's kind of our starting point with a lot of, as we engage with customers, we kind of start with that, right? So we start with, okay, we can get some standardized, and we've built some standardized pipelines, right? So we've built standardized pipelines around CloudFormation management, around provisioning code management, be it Chef, primarily Chef, a bit of Puppet, but mostly Chef. AMI provisioning. So we've got a standard way we build AMIs, right? We use Packer, and we've kind of templated all that, so we can kind of start with that. We can basically start with the customer, say, we've carved your application out to a bunch of tiers, we can bake all those different tiers. I'm a huge fan of immutable infrastructure, so we like to kind of build AMIs and then take those AMIs and deploy them in different environments. We use CloudFormation to kind of manage the propagation of those between different environments. And so yeah, we kind of have kind of really tried to push the boundaries in terms of working with customers and kind of managing, the kind of fundamental pieces around some automation. So taking some opinion in that process, which doesn't always apply, and we kind of customize it based on requirements, but really sort of like, I have this, I kind of have this view about this. You could document something, right? So someone could come along and read it. But if you've got a process and you can train muscle memory, right? So that I don't necessarily need to see how a customer, their individual environment, but if I know how it was built and I've and that's built in a sort of standardized way. They could be doing slightly different things, but as long as the basics are there, I know where to go and find where to change something. You build up that muscle memory in the team. So muscle memory is a very powerful tool to develop within a team because it's once they have it, they can they don't necessarily have to know specifically what it's doing. They can kind of use their muscle memory to go and find, okay, this is where I need to go to find this piece of information. And it avoids over documenting things. It means that you can document the core process, and then for every unique instance of that, you're only documenting the difference. And that's really powerful, right? That is a really powerful context. And I think, the whole culture of DevOps is really about, okay, so how do we kind of build those tools and those processes to build that muscle memory? And kind of scale that. So base 2 is, we're primarily based in Australia, but we are expanding into the US. Probably a third of our customers are based in sort of North America, and we're actually ramping up the team here. So if you're interested, we are hiring, and if you like your water with barley and hops, and if you like your cloud with automation and scale, then come and talk to us. Come join our team.
Thank you. So Aaron, for others who may have come, I was really impressed with your background. You've been doing AWS for 10 years, which I didn't even know AWS was around. For 10 years, and you've been doing it pretty much since the beginning. Wayne told me to tell you guys that they are hiring. They're ramping up a lot of their business here in the U.S., where previously was in Australia.
Yep.
They do have customers here. Sardis is one of them.
Yep.
But there's quite a few in North America, I think Canada and
Canada,
US
South America.
and stuff. So really cool stuff. I feel like you guys are out in front where a lot of even the companies here in Kansas City are for CI/CD. A lot of people here have been trying to take their company on the CI/CD journey, and it's more of a pull than it is anything. So excellent. Thank you so much. Another round of applause.
Yeah, that's great.
Thank you.
I'm going to be sending out a survey tomorrow. I really hope we can get lots of feedback so we can keep on making the meetup better and better for you guys, because that's what this is all for. And if someone wants to name a bar down here that people can meet at if they want to, throw that out.
After this?
What?
After this?
Yeah, like right now.
Oh,
Like,
Ruins
bars-
Pub is across the street.
Yes.
Yeah, the Ruins Pub, pay by the ounce.
Ruins Pub?
So cool.
All right, you don't have to go there, but you should. All right.
If you're interested in open source